Hello everyone. Today we're going to be seeing the different movement modes in Squadron Strike. Now, because Squadron Strike is a sandbox style board game, it gives you the ability to use different types of movements for different types of universes. For example, we're all familiar with the motion of the spaceships in the 2001 series as obeying, all three of Newton's laws, and then we've also seen movies where spacecraft can basically speed up and slow down in space, thinking about free space, for example. We also have seen it where spacecraft themselves seem to operate almost like World War II fighters with their ability to kind of like bank and turn and whoosh and everything like that. That's going to be represented by the different movement modes. So basically, our movement modes are named after which one of the traditional laws of motion that we're following most closely. Mode 0 movement, of course, is we ignore all of Newton's laws. Mode 1, we're going to keep our velocity from turn to turn. Mode 2 is basically not only are we going to keep our velocity turn to turn, but we're actually going to be moving on whatever vectors that we apply thrust towards, which makes things a little tricky, as you're going to see in a little bit. And then finally, we have quote mode 3, which is actually not something represented in Squadron Strike. If you want to see mode 3, that would be all the regular Newton's laws plus fuel consumption causing acceleration changes. You're going to have to go play attack vector Tactical, which is another one of the Ad Astra games. Highly recommend it. It's what I came for and is a subject of another day. So anyway, let's go ahead and get started. So we're going to go ahead and start with mode 0, which is the simplest type of movement that you have within this game. In mode 0, basically what you're doing is you're almost driving around like a tank or a cruise ship or something kind of like that. So before we do that, we want to go ahead and take a look at our move card, which is this guy real quickly. I'm actually going to bring our model up here so it makes a little bit more sense. So this is called an Avid, and this whole thing is called a movement card, which is going to make our life much, much simpler when it comes to planning different movements out. So in this particular case, as you can see, we have our model and it's sitting here parallel to the actual table itself. You can see it's got little symbols here. If I were to flip this guy over real quick, you can see it's got another symbol up on the bottom as well. Of course, now I've confused it because he actually doesn't have any gravity. So what we want to do when we first start a game is we want to go ahead and take the orientation of our little box and copy it onto the Avid itself. So I'm going to go ahead and get myself a little bit of a black pen here. Go ahead and shrink it down so you can actually see it. So now these are the different symbols we use for the different parts of the ship. As you can see right now, we can see this triangle representing the top front of the ship. And it is parallel, which means it's going to go in this yellow ring. If our model was tilted up a little bit, let me get this out of the way for just a second, such as at a 30-degree arc like that, then our nose would be shifted to this ring here. Now, if we were at an even steeper angle, say 60 degrees, that would make our nose shift to right here. Then finally, if we're straight up like this, our nose would actually be pointing right here. Now, I know some of you are probably going, well, can we roll the ship? The answer is yes. Although from personal experience, rolls don't happen that often unless you're trying to get a particular weapon in a particular arc. So anyway, let's go ahead and transfer this information over right now. Again, this is no matter what movement mode we're using, we always take a step to go ahead and update this. Go ahead and do this. Our top is going to be here. Our bottom is also going to be here, but we can't see the bottom through it because my marker is just a little bit too big here. Go ahead and mark that as the tail. Cool. Let's go ahead and get started. Now, in mode 0 movement, basically we have the ability to speed up and slow down on demand up to half our speed. So if you take a look, our maximum thrust here is 5. Ignore the mode 2 for a second here, which means we can change our speed up to 3 each turn. That also means when we take our end of turn marker, which basically assists the other player in knowing where you're going to end up, we always use half of that speed regardless of your current speed. Confusing, right? So I'm going to go ahead and move him where he's going to be expected to go. How do I know the end of turn marker is going to be there? Well, it's 5. 5 divided by 2, round up, is going to be 3. And since we're pointing straight parallel to the board here, that means that our end of turn, if we just moved maximum of our speed there, would end up there. This can change. In mode 0 is very famous for being able to basically tweak this around, especially if you're a very, very high thrust craft. So anyway, if we go ahead and take a look at our sequence of play here, you'll notice that all plots, pivots, and rolls are done first. Then we go ahead and do everything as far as vertical and horizontal moves. This is going to be more important when we get to mode 1. Then we make all of our changes. Note here, this is very important, that we're going to move to the end of turn marker towards the end after we pick our speed. And again, that's all our combat and stuff like that. So let's see what this looks like. So let's pretend, for example, we want to accelerate up to a speed of 3. Remember, we can't do 4 because of the fact that if we do 4, then we'd be going too fast too soon. So what we do is we go ahead and make ourselves a little note that we're going to be going ahead and bringing our speed up to 3. And then when it came time to actually plot our movement, we get a little bit of play in what that 3 actually looks like. So if I actually scroll down here real quickly. Oop, I didn't mean to do that. What I meant to do is write the letter A. There we go. We actually have a little bit of play in what 3 movement looks like. So basically, I'm going to leave myself a little note here too. Actually, that wouldn't go there. That would go right here because that's our actual speed we're going to be using. So if we were pivoting, we do that, but we'll deal with that in a second. So we actually, like I said, have a little bit of play. We can just go 3 forward like we plan to, or we could actually go up 2 and then over 1 to the right. So in this particular case, when we actually move, we would have done that. Now we move our end of turn marker again, which again is based on half of our top speed, and it's going to look like that. Pretty fancy, pretty fancy. All right, let's go ahead and erase this and make things a little bit more complicated. All right, so our speed from last turn was 3, so I'm just going to leave that in there right now. And we don't actually need to mark this using this mode of movement. Sometimes people like to do it. Do what works for you. Okay, so in this turn, we want to pivot and we want to just kind of keep on cruising. So whenever you pivot, the pivots always come after the movement. That's kind of an important kind of little concept here. So what I'm going to do is I'm going to increase my speed up to 5 this turn. How can we do that? It's less than half of our maximum thrust available at this time. This end of turn marker won't change, however. So when we get to the set, oh, by the way, we wanted to pivot also. So I'm going to go ahead and pivot 1, 2, 3 windows right here. There we go. So we mark the pivot like that, and we have, of course, our extra movement. So when it comes time to move to the end of turn marker, again, we're not going to be going here. We're going to be going 5 forward. 1, 2, 3, 4, 5. And then we're going to be pivoting. And essentially, we've basically gone like that, kind of taking a really, really, really tight turn. Then when we get to the step where we record the new Avid orientation, let's go ahead and update everything really quickly here. We'd have something that kind of looks like this. Right wing, if you want to consider that a wing, there's probably no wing. We'd then go ahead and clean this up. And now our new speed would be 5, just like that. And we then would take our end of turn marker and we put it at the usual 1, 2, 3, 1, 2, 3, and we're all set to go. So you can see in this particular case, we basically went and took a very, very tight turn, but we also moved our 5 hexes first. Now let's get things a little bit more complicated. Let's say we want to climb into the vertical. So in the next turn, let's say I want to take my nose and I want to move it, let's say 1, 2. I'm going to move it right here. What does that mean for our movement? That's actually not going to be that much problem. Actually, I'm going to go ahead and put this over here just to kind of remind me what I'm going to do here. That's not going to cause many issues because as usual, we're going to be moving our speed first. So let's slow down before we make this climb as well. So I'm basically going to reduce my speed to 2. And when we get to the actual movement phase, this is what's going to happen. So we're going to move forward 2, which if we're concerned about that, we can be very precise. There's only one possibility for movement of 2. We're on a hex edge here, 1, 2. And now what would happen is we do our pivot. We're going to be pivoting 1, 2 upwards. So 1, 2. Actually, before I do that, let me go ahead and rotate them. Whoa. Got to clean up the rotation. We're actually facing this direction now. 1, 2. Go ahead and line it back up. And we get something that looks like that at the end of the turn. But notice now our speed is only going to be 2. Again, that's the basics of mode 0. So if we wanted to go ahead and go through the actual step of cleaning all this up, let's go ahead and clean this up real quick. This would be recording our new Avid orientation. So our speed last turn was 2. Our nose is now pointing like this. Our tail is now like this. It's also below us. Let's see here. This would have moved 1, 2, 3. So our top is now over here, which means our bottom, try not to think about this too hard, would have shifted forward, and our wings actually remain in exactly the same spot. Checking that out real quick, it makes a lot of sense. You can see our bottom is actually not quite ahead of our top. So our bottom actually would be shifted backwards. And what our top, no, our top would also have been shifted back too. Okay, cool. So I think, let me just take a look at that real quick. No, that's pretty good. So we end up with something that looks a little bit like this. So now if we were to go to the next turn, and let's say we want to up our speed back to 5 again. So we're going to go 5 this turn, but we're not going to pivot. We'd end up moving. Oop, somehow my guy got a little out of whack here, but that's okay. Oh, before I do that, I want to mention that after we've made that, we have to adjust our end of turn marker. So in this particular case, since we were facing up at 3 at the time, if we go in this arc, which is the blue arc, up 3, 1, 2, 3, that's going to bring us up vertically a total of 2. So we're going to have to go ahead and get 2 of these. My bad. 1, 2, and we'd stick this guy on top. Okay, now we're honest again. So now this turn we actually decided to go 5 instead of going 2. So what does that mean for us this time? So instead of moving to this marker right here, we would go ahead and use our new speed of 5, which would get us one of these blue ones. But of course it'd be 1, 2 out, because if you're 2, no it isn't. I'm sorry. My bad. So in this particular case, what we'd have to do is plot vertically as well as horizontally. Since we're facing towards B, first we're going to do a horizontal plot. Remember, we're using 5 here, so we need to find any of the blue ones with the number 5. So for example, if I wanted to pick this one right here, that would give me 4 vertical and that would get me 4 horizontal. Then we'd come over here and plot our 4 horizontal, which in this case, I'm going to keep it nice and simple and do that. Now we'd go and grab this guy and make our little adjustment here. In this case, we've only gone up 4, so we would have actually grabbed 2 of these whites. 1, 2, 3, 4. Everybody gets plotted there, and now we would have gone like this. Go ahead and grab that. I'll go ahead and do a little rotation so it's a little easier to understand. Let go. And it would look something like that. So now we've actually gained a little bit of altitude. Is that 4? We already had 1. No, we didn't already have 1, so that's accurate. So that's the gist of mode 0 movement. It allows you to accelerate and decelerate on demand, which is kind of useful. All right, let's go ahead and take a look at mode 1 movement. Go ahead and clean this all up. So mode 1 movement is kind of like mode 0, except that you keep your speed from turn to turn, and the only way to slow down is by turning. So I'm going to go ahead and clean all this up real quickly. All right, so go ahead and update our avid orientation. Go ahead and give this thing a little tail. Our roof is now going to be where it belongs, on the top. So if we had no initial velocity, we could choose any velocity to start, which would mean our end of turn marker would actually be placed here. So taking a look at the rules of play here, if no pivot, add half the thrust to this turn's speed. So we're going to be using a thrust of 5, which if you remember is our thrust down here. So that means that my turn's speed is going to be a total, we're going to be adding 5 thrusts, but my turn speed is only going to be 2. Now you're probably saying, why is it only 2? That's because that when you accelerate, your new top speed only is going to affect you after this particular turn because it takes time to get up to that speed. So when we do things like that, add half the thrust to this turn speed. So our turn speed is going to be 2, which is half rounded down. So now what we have to do is adjust our end of turn marker. So in this case, our end of turn marker would actually be right there, even though our speed next turn is going to be 5. So when we get to the move to the end of turn marker phase, we jump up like this. So now what we do is we record, going down just this list right here, bleed speed from pivots, not an issue, add speed from thrust. So in this particular case, if you remember, our speed this turn was 2. We have no pivot penalty, which means our current speed for next turn is also going to be 5. Let's go ahead and erase all this. There we go. Which means when we adjust our end of turn marker, it's going to be all the way over there for the next turn. So let's go ahead and make things a little bit more complicated. So let's say we did all turn and everything like that. So now we want to go ahead and actually turn this vessel. By the way, what we could have done is come down here and we could have moved either one of these if we so desired to kind of shift, but we'll deal with that in just a minute. So now we're moving at 5 speed. So what we want to do is we want to just kind of keep on moving at that 5 speed. We could even build up to 10 speed or something like that. So I'm not going to change or add any thrust here. I'm just going to leave it at 5. We're not going to pivot or anything like that. But this is where things get kind of cool. So what we can do is, since we're facing A and we're doing 5, we're not doing anything vertical yet, we can actually go ahead and pick one of these guys with a number 5 on it that we can actually turn towards. So for example, if I pick this one here, 1, 2, 3, 4, 5, When I move this turn, even though my end of turn marker was right there, I'm actually going to move to right there, and that's still considered a legal move. All right, let's go ahead and get things a little more complicated, as always, right? Let's say we want to go ahead and turn the ship. So we get back to our first step, plot, pivot, and roll. So what I'm going to do is I'm going to do my classic rotation here. 1, 2, 3 is going to be my rotation. If I thrust and turn, there is no displacement. The other thing with turning, or I should say pivoting, as well as thrusting or not thrusting, is that you always do the pivot after the thrust. So in this particular case, if my speed was 5, we don't add any thrust to it, that means I'm going to be moving a total of 5 hexes this turn. But one thing that's going to get complicated, as you'll see in a minute, is when we move windows here, each window is going to knock 1 off of our speed when we consolidate everything at the end. So anyway, let's go ahead and move here. So let's say our end of turn marker, this would have actually been 5 ahead of us. 1, 2, 3, 4, 5, because that's where that belongs. So there's no vector changes, just end of turn marker for thrust displacement. Not an issue, since like I said, we didn't actually apply any thrust. So then we move to the end of turn marker. So let's see here. What's that going to look like? I think we agreed on that one right there. Going to do something just like that. And now when we adjust our end of turn marker, things get a little bit fancy. Because we moved 3 windows, it becomes 5 minus 3, which means our new speed is now actually going to be 2. Like that. So now I grab this guy and put him right there, just to give everybody a heads up where we are. So we lost quite a bit of speed in that turn there, just like an airplane would, interestingly. So when we come back over here, we'll just go ahead and clean that up real quick. And now our new orientation is going to be looking something like this. Just like that. And we're going to be doing 2 speed. So let's say we want to apply thrust and change our pitch at the same time. So this is going to be a little bit more complicated. So what we're going to do is we're going to go ahead and add thrust. We're going to add all 5 thrusts today. So remember, whenever we do displacements, we always would be adding half the thrust rounded down. However, since we're also going to pivot into this position, we don't actually do that, which means the total speed this turn is only going to be 2. Of course, it's going to be minus 1 because we're pivoting. So let's see what that looks like. So we can only move 2. So in this particular case, we're facing an edge, aren't we? So we have B and C. So we can pick any of this. There's only one choice there. So 1, 2, perfect. So when it comes to move to end of turn marker, our craft would come up like this, and let me grab it. It would also pitch up to 30 degrees like this, which of course, as we saw before, is going to take our nose, it's going to put it right here. It's going to leave the 2 wings alone. It's going to take our top. It's basically going to shift it to right here. It's going to take our bottom. I'd circle the bottom, but you can't actually see it. And of course, it's going to take our tail and actually shift it underneath. So it's down here, and this would also have a circle on it as well. So you have a pretty good idea of what that actually looks like. So since we shifted 1 pivot here, we'd be losing 1 to our speed. However, we added 5, and our original speed was 2. So, whoa, that's a lot of math right there. So 5 plus 2 is 7 minus 1 gives us a new speed of 6. Just like that. So now we go ahead and adjust our end of turn marker here. So in this case, place end of turn marker for current vectors and speed. We have a new speed, and it's a speed of 6. However, we know that the speed is going to be in the blue arc this time. So speed of 6, if I just measure it straight up, would be this guy here, which would be 3 higher and 6 out. 1, 2, 3, 4, 5, 6 out, and 3 higher. So that would be our new end of turn marker. So let's go ahead and move on to the next turn now. Everything's happened. We've done a combat. We've done all that other good stuff. I'm actually going to grab everybody and move it over so it's a little easier to see. So let's say now we're just going to be climbing vertically. We're not going to add any speed. We're not going to pivot. We're not going to do anything like that. So what's going to happen is when it comes time to plotting our move, we get to pick any of these markers in the blue that have a 6 in them. So in this case, I'm not going to add any more thrust, so we know we're going to be moving 6 blocks this turn. So let's see here. We can do this one, which gets us 3 and 6. We can't pick that one. We can pick this one, which gets us 5 and 4. Or we can pick the, oh, can't pick that one. Oh, nope, can't pick that one. Oh, let's see here. That's only going to get us 2 vertically. I want the one that gets us a lot vertically. So it looks like that's going to be our winner. That's going to get us 4 and 5. So that's going to increase our vertical altitude by 4, and is also going to increase our horizontal by 5. So I'm going to go ahead and spot that one real quickly. We're still facing BC here. So that's going to get us, if you remember, a total of 5. So 5, 1, 2, 3, 4, 5. So I'm going to pick the one that's slightly off to the left. Taking a look at this one, like I said, it's going to bring us up 4. So when it comes time to actually moving to where we're going to be moving to, we're going to be adding a total of 4. So in this particular case, this doesn't happen very often, but our end of turn marker is actually pretty close to the actual altitude we're going to end up at. But remember, though, is we're only going to be moving 1, 2, 3, 4, I should say 5 out. So let's see, 1, 2, 3, 4, 5. So it's actually going to move this here. So we've shifted ever so slightly to the left as we've done this maneuver. I'm going to move that out of the way, grab our cutter, park him up on the roof, and we get something that looks a little bit like that. So now we need to adjust our end of turn marker again, which again, we're going to be assuming that we're moving at the current speed here, which is a speed of 6. So 6, again, we want to pick the one right in the dead center of the blue, is going to increase our height by 3. So that's going to get us a blue for 5. 1, 2, 3, 4, 5. What is that actually going to get us in that direction if we pick that one, though? That's going to get us 6 in that direction. So yeah, it's going to be 6 away. 1, 2, 3, 4, 5, 6. And we're going to be adding a total of 3 height to that. So that's 5, 6, 7, and that's where my end of turn marker would be. And that's basically going to be it for moving in 3D with mode 1. Let's go ahead and take a look at the complicated one, which personally makes the most sense for me. Go ahead and clean that up. And that is mode 2 movement. In mode 2 movement, basically you're going to be inheriting whatever velocity and vectors that you were traveling in before. This gets a little bit more interesting. Let's go ahead and update our Avid real quickly. Go ahead and put our little tail right there. Our roof's going to be right there, and we're good to go. So in this particular situation, we're basically going to be treating the spacecraft as an actual spacecraft, how it moves through, an actual space. When we apply thrust, we only get thrust in the direction we're applying thrust towards. So let's go ahead and demonstrate that. So if you remember, we have 5 thrust here. So at the beginning of our turn, we applied any pivots or rolls. We're not doing any of that. We're not pivoting. There's no half thrust. There's nothing along those lines. Plot, vertical, and horizontal move. So what we're going to do is we're going to thrust in the direction of A. So what is that going to look like? It's pretty straightforward. We're just going to come up here, and we're just going to write the amount of thrust we're going to be putting in A, which is going to be equivalent to 5. So in this particular case, that's going to cause us to have a little bit of displacement. Displacement, like I said, is basically because you're spending the whole turn accelerating, you're going to have gone faster, which means you're going to go farther in that particular direction. So adjusting the end of turn marker, we're going to take half of this rounded down. So I'll go ahead and move that guy right here. Now here's where things get a little complicated. And you'll see a little bit of this later on, depending kind of how things happen, is now when we move, we're only going to be moving to that spot. Now, if we had an odd thrust, which we do have an odd thrust, you end up accumulating what they call a half a thrust in the direction you're thrusting if you don't when you round down. So in this case, if you remember, our displacement would normally just take us 2 forward. It actually takes us 2.5 forward. So what we'd actually do is we'd come here and make a little dot right here to kind of remind us we have an extra half a bit of speed in that direction we got from accelerating. So when we get to the move to the end of the turn marker stage, we're going to go like this. We're going to go ahead and move right down the list here. That doesn't change. Consolidate and record new vectors. So in this case, whoops, I mean accidentally delete him. We're now moving 5 basically into half in that particular direction. So when we adjust our end of turn marker, 2, 3, 4, 5, it sits right there, even though our speed is 5. So that's the easy stuff so far. So let's get to the complicated stuff. So next turn comes around, we want to do a pivot. We'll do our standard pivot here. We'll go ahead and pivot 1, 2, 3 this direction. We're just going to do a standard pivot here. We're not going to thrust or anything like that. So as usual, we always pivot after we move. So we're not changing any of that. None of that changes. So here's what would happen. Our spacecraft would move to this position. 1, 2, 3, 4, 5. And my end of turn marker would move to that position. But now we're facing that way. So notice I can change the nose position and keep moving. And this is one of the most fundamental features of space combat. So let's go ahead and update the Avid. So now we're facing this direction. even though we're moving that direction. Pretty cool if you ask me. And we have something that looks a little bit like this. Remember, we still have a half. Remember that half a hex we accumulated a little while ago? One of the unwritten rules or written rules or suggested rules is whenever you pivot, you should always erase those little half marks. It just makes things a little bit more difficult to keep track of. Okay, so now, of course, we'd go to the moment where everything's been moved. We're all set and ready to go. So we get to our next turn, we say, well, we want to pivot some more and we want to aim towards C. And we're also going to thrust at the same time as we pivot. Whoa, okay, that gets a little more complicated. So what we're going to do is we're going to use 5 thrust again. So we're also going to pivot. So 1, 2, 3. I'm going to move to this little point right here. And I'm also going to be applying 5 thrust. So what I'm going to do now is I'm going to record the midpoint of the thrust. Pretty straightforward. Let's see, 1, 2, 3. So halfway, the midpoint rounded down is going to be right here, which means our thrust as we rotate is going to be going through C, which is going to be a total of 5 thrusts. You'll see how that works in a second. So now we just do everything we do. You do not displace when you pivot. That makes things a little bit more complicated, and you will see that if you do attack vector. So anyway, we go ahead and adjust end of turn marker for displacement. So if you remember, we're turning as we're burning. So we're going to be adding all of our thrust to C here because of the fact that, like I was saying, this is going to be the midpoint of our thrust. So I'm going to go ahead and put a 5 right here. So now we go ahead and move to the end of turn marker. We're still going to be going to the end of turn marker. However, when we're done, we're going to be facing this direction. So now we end up with a situation that looks like this. Let's go ahead and clean that all up real quickly. So now we have a ship that's like this. But we have a vectors of 5 that way and a vectors of 5 that way. How does that work? It actually works really, really easily. Basically, what you do is you take the smaller vector, subtract it from the opposite vector, and then add it to the one next to it. So if we subtract 5 from 5, you're going to get a 0. If we add 5 to 0, you're going to get a 5. And of course, you subtract from this one as well. 5 minus 5 is going to be 0 also. So what we've essentially done is we've pointed this way to shift our direction this way. So when we mark our end of turn marker, it's actually going to look like that. We've basically gone straight and started to kind of burn around this direction to kind of come back the other way. So if we were to move, we might not apply any thrust or anything, we'd actually shift that way. So let's go ahead and get complicated again. So rotations and all that other stuff is exactly the same. So what I'm actually going to do is I'm going to pretend we have a situation like this. We have movement of 3 directly off the nose, just like that. We want to go ahead and pivot to climb. Things are going to get a little bit easy here. So basically what we're going to do is we're going to call our pivot. We're going to pivot 2 to here, which is going to put us right there. And we're also going to be thrusting using 5 this turn. Oh, that hurts your head a little bit, doesn't it? How do you work that out, kind of thing? So we have a plus speed here, and we also have our speed here. So we basically need to pick with our 5 thrust what goes where. So for example, if I wanted to, we could have 3 go vertical, and we could have 3, actually it would be 4 go horizontal. We could also come up with a situation like this, where we put a little bit more horizontal into it. Personally, I want to do as much vertical as possible. So it looks like we can get 4 and 4. So that would mean, wait, that makes no sense. We're doing 5 thrust, 3, let's see, 4. No, that's what it says, 4 and 4. There's a rounding issue. So that's going to add 4 here, and that's going to add 4 to my vertical speed as we go ahead and pivot upwards. How's that for incredibly confusing? That doesn't sound right. I'm just looking real quickly. No, 4 and 4, that's what it says. It's 5 thrust, but that equals 8. It hurts my head. Oh no. So anyway, so when it actually comes to the turn itself, we're going to go ahead and move like we normally would have. Remember, we're going to come forward our 3 marks here. Our nose is going to pivot upwards, just like we planned. 1, 2. It's going to be like that. But now when we consolidate everything, let's go ahead and clean this up a little bit. We're now going to be moving speed 7 in this direction. And now we're going to be having a vertical speed of 4. Go ahead and clean that up again. Again, our nose would have been all the way up. Whoa, I think that's a line. Our nose is going to be here. Our tail is going to have dipped underneath. our wings are, if we had wings, our sides are going to be like this. This guy would have tipped to this guy, and this guy would have tipped to this guy. This would be underneath us, is now going to be in front of our nose, if you want to think about it another kind of way. Tough to see. But now our vertical speed is 4, and our forward speed is 7. So when we go to adjust our end of turn marker, we need to get 4 of these. 1, 2, 3, 4, 5, 6, 7 away. 3, 4. That's what our end of turn marker would look like. And if we don't apply any thrust or anything like that, that's where we'd end up at the end of the turn. Now, that's pretty much the examples. So let's go ahead and take a look at some weird situations that you might bump into. And I'm going to ignore all this stuff here. Now, let's say after you do all your thrusting and burning and stuff like that, you run into a situation that looks like this. How do we deal with that? That's pretty straightforward. What you're going to do is take the smaller number, add it to the one next to it. So 2 plus 3 is going to equal 5. And then you take that small number and subtract it from the two outside ones, which is going to leave this at 2, and drop this to 0. So my new vectors would be 5 and 2. Another word on vector, sometimes you get a couple other little funky things that happen. It's basically vector addition. Sometimes you end up with a situation that looks like this. We have a downward speed of 2, and we have an upward speed of 3. These are opposite each other, so you simply subtract them. If you do something like that, you're going to end up with 1 here, and you're going to end up with 0, so we're still going up. The opposite is also true. Let's say we have a speed of 4 here. We have a speed of 8 here. Let's make this nice and complicated. And let's say we have a speed of 3 over here. Okay, how do we deal with this? Start by taking the opposite ones first. So 8 minus 4 is going to be 4. And that's as much work as it took. Now, if for whatever reason that this 3 was actually down here, we just use the process we did before. So this would go to 0, this would go to 3, and this would go to 1. Just like that. Of course, we get rid of that guy. And that's the basics to the different movement modes in Attack Vector. When you do things with tractor beams, things get a lot more complicated, but I've intentionally skipped those steps because that is definitely for another day. Enjoy!